Before lunch, can I have your attention now? Before lunch, we were looking at plating. And the last thing that we have to do with electrolysis is just calculate how much of a metal can be plated onto a surface of an electrode in terms of grams. You're going to find it to be very straightforward and systematic. Oops, we don't want that. Okay, so this is as far as we got before lunch. I've just got a little process to show you involving the stoichiometry of how to figure out how much plate. Now, yeah. Thanks, okay. Oh, yeah.
Saving the date.
Good work. Thank you. Now, we've been talking a lot about voltage. Voltage is joules per coulomb. Tell us how much force, and I'll use the term kind of loosely because it's not physically a force, but how hard the electron is being pushed from the anode to the cathode. When we want to calculate how much of a metal plates, we have to use its current. The number of electrons coming through dictates the current. So current is measured in amperes, which is a derived unit. It's coulombs per second, as you see. So if you can figure out, not even figure out, but if you can measure what the current is of a circuit and how much time it runs, you can determine how many moles of electrons have been sent over. Then we'll be able to determine what the mass of the metal that got plated was. Now this is a process for solving. It's got 5 steps, and don't be intimidated by 5 steps, except for Peter Nam. He got up and walked out after the first 3. Too much for him.
Too much.
But it's not bad. First thing you want to do is make sure that the time is in seconds. So if it tells you that the circuit ran for 20 minutes, convert it to seconds. If it was an hour, convert it to seconds. The reason that we have to convert to seconds is so that we can use that current to change it to coulombs. I'm good. Actually, I did just eat an orange and a little bit dry, but I'll wait till later. I'll get it later. Does it make me smell like a girl? Okay, so we'll get the time in seconds, and then we're going to multiply the number of seconds times the current, and that tells us what the total charge, how many total coulombs have been delivered into the cathode. Now, this gets us into coulombs. What are coulombs related to that we've learned about? It's Faraday's constant. Faraday's constant relates coulombs to what?
Coulombs to...
Remember that number for Faraday's constant, 96,045 coulombs is what?
Coulombs per 1 mole.
Moles of electrons. 1 mole of electron has a charge of 96,485 coulombs. Okay, so that's our next step. Once we have coulombs, we're going to use Faraday's constant, and we're going to find how many moles of electrons came in. So if we know how many moles of electrons came into a cathode, then we can use the oxidation number. Let's say that it's zinc. Well, a zinc ion needs 2 electrons for every zinc that plates. So it depends on what the oxidation number is. You can figure out how many moles of the metal reduced. Okay, and the last step is, once you know how many moles of metal reduced, then it's just converting to grams using the molar mass of it. So this is 5 steps, but it's very, very simple. You'll wish that all the problems were like this. This is probably the one time this year that the last thing that we do in a chapter is easy. Normally I'm sticking to you with something really complicated at the end, but not this. So we'll do a couple of examples together, then we'll be done.
No, I have a pencil.
Okay, we good? So I'll do this one with you, show you how we use the 5 steps, and then I'll have one for you to try. Now this is right from the book, that's why there's a part A. There would have been a B and a C as well. What mass of each of these, there's just one, can be produced in 1 hour with a current of 15 amps? So assume that we have some electrochemical setup, it's electrolysis, and we are sending electrons into a solution of cobalt. The question is, what mass of cobalt is going to plate on the electrode? Cobalt is super good for tools. It's a very hard metal, durable metal. So they use cobalt in like drill bits, things like that, that might tend to wear down if you don't use good materials, but cobalt is used for that. So this is not something that would be unusual to do. You would make up a steel drill bit and then plate it with cobalt, make it very hard on the outside. Here's what we do. First thing is, take the amount of time that the current ran and change it into seconds. So we have an hour, easy enough. That would be 3,600 seconds. Then take that time and multiply it by the current. Because the current, remember, is coulombs per second. So this thing right here is what we're going to use. 15 coulombs in every 1 second. That's a lot of coulombs that came in. All right, now what are coulombs related to? Faraday's constant. That is how many coulombs are in 1 mole of electron. So we've canceled out the seconds, and now we have the charge unit. And it turns out that 96,485 coulombs is the charge of 1 mole of electrons. That cancels out the coulombs. So what we've gotten up to here is, this tells us how many moles of electrons came into the cathode. And that is going to be used to reduce cobalt with. Well, how are electrons related to cobalt? Take a look right here. You see that every cobalt ion is a positive 2 charge. So in order to reduce, every cobalt needs 2 electrons. So if we're going to reduce 1 mole of cobalt, we would need 2 moles of electrons. Yeah? Yeah. So, what? Yeah, see how the cobalt is a positive 2?
Yeah.
So every cobalt needs 2 electrons?
Okay.
So if we need a mole of cobalt to reduce, it would take 2 moles of electrons. And that's what this conversion is here. 2 moles of electrons would be needed for 1 mole of cobalt. And this gets us into how many moles of cobalt would have been plated, and just change it to grams. The molar mass of cobalt, 58.9, I think, grams of 1 mole. That's it. That's how we do that. So the units kind of lend themselves to just what the next step is. We're only allowed 2 sig figs, so we have a current that has only 2 sig figs. We'll call it 16 grams. 16 grams of cobalt. Anybody have any questions about that?
Oh,
Shall you try one? Yes? Now this one is not the exact same problem. There's a little twist to it, but it's not bad. See what you do with this one. Good problem.
oh. You play this. Yeah, you can. A lot of people. No, you can't just think. I don't archive this stuff in time. And you can just use it. He said this sound like no one else. So it's silent.
Did you? One more telescope. You can't destroy creation system. Because of, yeah, exactly. 'Cause the creator was created. Yeah. Sorry about that. Look at this.
Okay, so I hope you're on track on this. I would just run through it the same way that I did the last one.
Because it's NO3. Yeah.
So you need 3 NO3s to balance the charges. If that's a -1, it has to be a +3. Sort of plate it, reduce it totally to 3 electrons.
I can't even see. I'll just find out. When you say it, they're like, yeah, that's what.
The X plus like the last name.
No, you're saying you're.
No, because this is a solution, so the M is broken apart from the NO3. Yes.
Is it possible for different elements, to have like really close?
Yeah, that's what you have in this case. There would be really 2 correct answers for this one, because they both get you to the same molar mass gets you to 2 elements. Yeah.